Programming rarely is a walk in the park. Errors will happen, and we have to deal with them in a reasonable fashion. Let's say we have the following function that takes the string representation of an integer as its parameter and returns the appropriate int as its result. If we feed it something like 8 or -147, everything is fine. But if we call it with "hi there", it has to act in some way. It could return a magic value like 0, -1 or numeric limits int max. But all these approaches carry the risk that the calling side does not handle it correctly. So how about this? If the function succeeds, it returns true and has written its result into the provided int variable. If it fails, it returns false and does not touch res. This is slightly better than before, but still, the caller could just ignore the returned boolean. We could throw an exception instead. This makes it difficult for the calling side to ignore the error completely. It either has to catch the exception or let it fall through. In any case, it will not simply continue its work as if nothing had happened. But exceptions name our type signature a lie. It is not true anymore that the function returns an int every time. Sometimes it does not return anything and explodes instead. Such a function is not total. A function is total if for every input the type system allows, there is a good-natured output. Also, we have to rely on comments again, and dynamic exception specification is deprecated in C++ standard for good reasons. So what about this? On failure, the function would simply return a null pointer. This seems to be a good solution at first glance, but the caller can still be careless and dereference that null pointer, making the whole ship sink. Additionally, a pointer suggests that something with a base class could be going on, not in the case of an integer of course, but it can in general. So we need something more explicit. This is where the maybe type comes into play. Here, the caller immediately sees that the function perhaps returns just an int, but could also return nothing. The two cases a maybe can be are actually called justInt and nothing. The caller now can check if the maybe is a just or a nothing and react accordingly. std optional is what the STL has to offer for this case. Optional is just another name for the maybe type and an equally good one. By the way, types like maybe are called sum types, or sometimes tagged unions. The number of different values these types can hold is the sum of the values the single possible types can have. Here with maybe int, it is all possible integers in case of a just and the one possible additional value in case of a nothing. But one can also create more complex sum types, for example, something holding either an integer or a string or a boolean. The number of possible values would then be the sum of all possible values of the three types. Additionally to sum types, there are product types. These types can have as many different values as the product of the participating types. Sum types and product types together sometimes go under the name of algebraic data types. Okay, back to our maybe type. You probably think that at some point the calling side still has to access the just value inside the maybe, and that is absolutely correct. But the great thing is, we can handle this without any risk of trying to access something that is not there in case of nothing. We can of course always ask the maybe if it contains a just or a nothing. And one simple way to access the just content is to use just with default. This will make sure one gets a valid value of the correct type. For now, the maybe is only slightly better than the share pointer approach, but the next two lectures will show more powerful ways to work with maybe values, and I think you will like them as much as I do.